Hello and welcome to 2.3 using principles together. So here we're going to be using the addition principle and the multiplication principle together to solve linear equations. And the thing that you want to keep in mind is the idea is that we want to isolate the variable, whatever it may be. I see some x's and t's on the page, so we're going to do that. So up here, for the people that like something that's more formulaic, kind of like do this first, this second, this third, this fourth, I've kind of laid out some rules is what you want to do. So first thing you want to do is clear fractions or decimals. We'll talk about what that means in the context of the problems. Second thing is remove parentheses if there are any. Third thing is collect like terms on each side. That's going to be something that we'll do. Fourth thing we do is we get all the variable terms on one side, all the number terms on the other side. Combine those once we move everything around. Last thing we're going to do is multiply or divide to find our solution. And the last thing we're going to do is check. Now, in the past two videos, I've done a lot of checking. I'm not going to check my answers on all these. My assumption is that you'll want to check your answers on things like exams and quizzes to make sure you have the right answer. But in general, as long as you're following these correct procedures, it shouldn't be too bad. So we're going to go to this first problem here. We have 4x minus 6 equals 34. So we want to get the x all alone. In order to get the x all alone, we need to get the 4x alone first. So we need to get rid of the minus 6. So we undo subtraction of 6 with addition of 6. So I want to add 6 to both sides. And that's going to get my 4x all isolated because 6 minus 6 is 0. So we have a 4x right there equals, over here, 34 and 6 is going to give us 40. So notice, we're kind of, we got all the number terms to one side. We have all the variable terms to the other side now. Last thing we want to do is get that x all alone. 4x is 4 times x, so we're going to divide by 4. Divide by 4. And when we do this, we isolate the x. We get x equals 40 divided by 4 is 10. And that's that. Now, normally you'll probably want to check your answers, but for the sake of time, I won't be checking them here today. So this next one, negative 4x plus 7 equals 35. Once again, if we want to get x all alone, the first thing we need to do is get negative 4x all alone. So we need to get rid of plus 7. So we're going to subtract 7 from both sides. That's exactly what we want to do. So 7 minus 7 is 0. So they cancel out, and we get a negative 4x. Over here, 35 minus 7 is 28. So notice, we got all the numbers on one side, we got all the variable terms on the other side. Last thing here to get x all alone is divide by the coefficient negative 4. Divide by negative 4. And here we get x equals positive divided by negative is a negative. We always want to kind of do that and make sure we have the right sign. 28 divided by 4 is in fact 7. So we're putting that right there. Okay. So the next one here, once again, if we're trying to solve this thing for t, first we need to isolate our 5/4 t. So in order to do that, we need to get rid of our negative 18, so we add 18 to both sides. Okay, so here, 18 minus 18 is 0, so we have 5/4 t equals negative 3 plus 18 is going to give us 15. Now, recall from last time, if we have 5/4 t, that's 5/4 times t, the way we undo this is by multiplying by the reciprocal 4/5. Because we're multiplying by a fraction over here, make 15 a fraction, the fraction 15 over 1, multiply by 4/5 as well over there. So now we look for this cross cancellation, or our multiplication. Here the 4's cancel, the 5's cancel, so we're left with just t. Over here, 5 cancels to 15, leaving me a 3 and a 1. No other cancellation, so we multiply straight across. Our 3 times our 4 is 12. Divided by 1 is 12, so we get t equals 12. And that's the answer we're looking for. Okay, so in this next one here, notice we have two variable terms on one side, so we want to combine these like terms. We want to collect these up. If we have 7x plus 18x, this gives us a grand total of 25 x's. Once again, we're adding the 7 and the 18 to get that 25, and these are like terms because they both have x's to the first power. That's going to equal 125. So now we have all the variable terms on one side, the numbers on the other. We want to get x all alone, so we divide both sides by 25. 25 divided by 25 is 1, so we get x, or 1x. 125 divided by 5 is 5. And that's the answer we're looking for there. Okay, so moving on to these last couple. Now, this first one here, we have 1/3 x plus x equals 8. Now, you could add the 1/3 x and the x by getting a common denominator. But there's another technique that I want to show you, and it's called clearing the fractions. And what we can do is this. We can make everything into a fraction. That is, we can think of this as a 1/3 x plus a 1/1x equals an 8/1. Now, if we were thinking about getting a common denominator for all these, the common denominator between 1, 3, and 1 is 3. So one thing that we can do, and as long as we do it to both sides where k, we can multiply everything by 3. Now if I multiply this by 3, multiply this by 3, which is, note, a 3/1, a 3/1, and multiply this by a 3/1, notice what happens. This 3 cancels with that 3, and we get cancellation, so we get x plus. Here, 3 times 1 is 3, divided by 1 is 3, so we get 3x. That equals 3 times 8, which is 24/1. Now notice, we went from something that has fractions, we multiplied by the lowest common denominator, that is, we multiplied each of these terms by the lowest common denominator, and we ended up with something that no longer has fractions. So that's a technique called clearing the fractions. You could combine these things with common denominators, or you can clear the fractions. Two distinctly different ways to solve a problem. I like the clearing the fractions because that's going to be what we're going to be doing in the future, so you want to practice that. So now we have two variable terms on one side, x plus 3x, so our 4x, that equals 24. And once again, 4x is 4 times x, so we divide by 4. We get x equals 6, and that's the answer that we're looking for right there. So on this last one here, we want to get all the variable terms on one side, and we want to get all the number terms on the other side. So I'm going to move all the variables to the left. It doesn't really matter if you move them all to the left or the right, but in general, students like to move them to the left. So if I'm moving all the variables to the left, I need to get rid of this negative y. So how we can move the negative y over is by adding y to both sides. Okay? So if I have 5y and we have another y, that's going to give us a grand total of 6y. Our negative 2 carries down, and we're going to get that over to the right side here in a second. Our 28 carries down, but negative y plus positive y is 0, so that's why we don't have anything over here. Now we want to get all the numbers to one side. Because we have our 6y over here, that means we want to get our numbers to the right, so we need to get rid of this negative 2. So let's add 2 to both sides. Negative 2 plus 2 is 0, so our 6y, we're good with that. 28 and 2 is 30. And then we've got this down back to the multiplication principle, where we can just divide both sides by 6, and we get y equals 5, and that is the answer we're looking for. So, see you next time for combining principles. The next ones get a little bit more hairy than these, so make sure you understand these really good before you move on to the next ones.